I'm leading the working group for remote sensing and spatial modeling at the Institute of Landscape Ecology in Münster. And my work is mainly focusing on developing and applying machine learning strategies for spatial data and in this context especially for remote sensing based monitoring of the environment. Well, I started studying geography in 2007 and I focused on remote sensing quite soon, so I think after the second semester or so. And then I did my master in environmental geography, it was called, but it was mainly focusing on remote sensing and spatial modeling. And when I continued with doing a PhD, postdoc and so on, and I was always quite impressed about the capabilities of remote sensing and what you can do with remote sensing data and spatial modeling, and that led me to continuing in that field. Well, probably what fascinates me most is what I'm also criticizing the most, and that is that you can so simply just take some remote sensing data and apply some simple functions and you get a great map of something, for example, of, biodiversity patterns or climate variables and so on. It's so, it's so nice to quickly get a map out of something, and then of course the challenge is to create these maps or these spatial continuous data that we're aiming at developing in a very reliable way. It's just quite impressive to what you can do with remote sensing data. Well, I started coding. Actually, it was quite early during my bachelor studies, and I just saw someone opening R and just typing something like x equals 1 to 10 and y equals, I don't know what it was, and then just typed plot x, y, and it was so impressive how that plot came up with all, so quickly, and was compared to what we were used to in Excel and so on. And then I thought, I like to do something like that as well, and then I taught it myself to get a bit into R, and then of course I was looking for courses on R to get better with that and not teach everything myself. Well, it's actually the fourth time that I'm at this summer school. So the first time was in 2014 as a participant, and then I started giving lectures at the summer schools 3 years ago in Prague, and then in Münster last year again, and this year. And it's great because when you develop methods, especially when you also do R packages and so on, you want others to use these packages as well, especially if you're convinced that they can be helpful for others as well. And I think these summer schools are a great opportunity to bring the ideas that you develop to others so that it can be picked up. And it also helps myself to manage the material that I usually develop more in view to writing scientific papers, so that I can reorganize everything and prepare it in a way that it's quite easy to get and to tidy everything up a bit and to focus on the major messages that I want to transfer. Mainly working with raster data in R, but more or less everything in R is great. And for teaching, I sometimes use QGIS, especially in the beginners courses, because I think it's quite nice if you start working in a more interactive way rather than starting with programming straight away, especially for those students that are not choosing to do any computer science in the first place, but studying landscape ecology and so on. So for most of them it's easier to first get access to this kind of analysis in a more interactive way, and then afterwards you can see what great advantages it has to do that in R, and that you can be so much more flexible when you do things like that in R or in other programming languages as well. So I use QGIS mainly in teaching to get started with spatial data analysis. For the field that I'm working on, and this is the field of machine learning for spatial data analysis. And I think what you can see is that everything is getting more complex. So a few years back, everyone started with applying so simple basic machine learning functions for their spatial data, and now everyone is switching to deep learning, and I don't know what's coming next. So I think it's, there's the trend that everything is getting more complex, and I think that's also kind of, or makes open science very necessary, because you have to be very transparent in what you're doing, because otherwise it's getting very hard for others to interpret the results or also to reproduce your results. And I think that's something that we need to be very careful with when we continue with more complex models. Yeah, so what me got into coding was being very enthusiastic about these things, so that you started with doing or data analysis in Excel or spatial data analysis in interactive GIS software. And it got me very enthusiastic to start programming, so that you can see how flexible you can be with programming things by yourself. And so what I try to do, because I do quite a lot of teaching at university, and I try to bring in a lot of programming already in the early courses in the study programs, so that I can try to get everyone enthusiastic about doing things like that as well. And then I hope that some of them will pick that up and might develop their own packages at one point as well. That's what I hope. So at least that was my motivation to start programming, so that I was just so enthusiastic about what you can do by that. And I hope that I can show others during my teaching activities as well how great things you can do by programming. Well, in terms of approaching such problems, I think what's good with open source data is that you can be very transparent about that, and I think that's very important, because there's always a problem that you might not trust results that are created, especially if you apply very complex algorithms to that. And I think you can only manage that if you are very transparent in what you're doing. And of course, it's also the speed that others can pick up these ideas, because if you're open with what you're doing, others can directly see what you're working on and develop other ideas around it. And I think especially when you talk about things that happen quite quickly, like the corona spread at the moment, I think you need to be able to analyze things quickly and also see what others are working on, so that you can develop around it and not trying to do the same things that others are working on already, but you're just not getting to know that.